All right, today we're going to look at scatter plots again, and we're going to be making our own scatter plot today. So what I've done is I've given you guys a set of practice data. You'll go ahead and plot those coordinates. I want you to set up your graph with the independent and dependent variables. Make sure you're careful when you graph these, make things very clear. And then once you look at that, I want you to take a look at this graph and decide, well, is this, can we see a correlation here? Is there a correlation? Is it positive? Is it negative? So if you're looking at this one here, it looks like it's got a correlation. To me, it looks like it's a positive correlation, okay? We're gonna take that a step further today. We're going to make a line of best fit. And when we go to do that, it's good if you can find some kind of a straight edge to use. I've got a tape measure here, and start looking at where's the trend line going? Where's the best place to put that trend line? And ideally, you want to put that through a couple important points. And I can see here that this looks like this is probably going to be between these 2 points here. That seems to show what the trend line is. So if I go ahead and connect those 2 points, okay, with my line of best fit, okay, and that represents the trend that we see, okay. That's really the purpose of a scatter plot and then a line of best fit, is that represents that trend. Also, if we look at, do we have any outliers here? I guess we could say this might be an outlier. So in the data set that you have, you may also have an outlier. So the next step is to let's make an equation for this line of best fit, or it's the function. Now, you're going to be comparing height and weight. And as height increases, so that is the independent variable, the weight is also going to increase. Okay, so this was taken from a number of students, and you'll see that we'll have a negative weight, which can't happen. So this doesn't always work. Sometimes the trend only works after a certain age. So for example, the proportions of infants is different than with adults, and so on. So these trends don't work forever, but they do have use to predict some of the things, okay? So let's go ahead and find the equation for the line of best fit, okay? And we know when we do that, we're gonna say y equals mx plus b. If I was just gonna estimate it right now, you know, it looks like the slope is somewhere close to 1. And also the y-intercept looks like it's around -2 or something like that, okay? But let's just use these points. So we've got 3, 1, okay? And we've also got, looks like we've got 7, 5, okay? So what we need to do is find the slope, and then we're gonna go ahead and substitute one of those points in again to get what the y-intercept is, okay? So, our slope is, we're going to take the rise over the run. So we go from 1 to 5. So m is equal to, the rise is, we know it's positive, 4 over, and the run, okay, we're going from 3 to 7, so the run is 4. So again, m is equal to 1 here. That makes things pretty easy. We don't have any fractions to deal with, okay? So let's just go ahead. We've got y equals x plus b. And how do we find out what b is? We need to go back and substitute. And you may have some kind of a fraction that's not so fun to deal with. You'll still have to do the same process and then find common denominators to do that. So let's go ahead and substitute. I think it's easier to substitute this one. This is my x and this is my y value. So I'm going to substitute for y here. And I have 1 is equal to, and for x, I have 3 plus b. So b, if I subtract 3 from both sides, is -2. So the function f of x is equal to x minus 2. Now this is not so typical of the function that you'll get from raw data. You're going to have some kind of decimal values and things like that. All right, so what your exercise to do today is to do the same for the data set that I gave you, keeping in mind that our goal here is to take the data that we have from our ASC project and then go and interpret that